Hello everyone, welcome again on Tips Engineer Zone. Now we are learning about load loss calculation. Okay, in this calculation we can calculate load loss of the three-phase transformer. Okay, so first I will tell you the what is the process to calculate the load loss calculation and HV and LV. Okay, this is the YND11 transformer. Okay, this is the HV winding is a star winding and LV winding is a delta winding. Okay, so look here, this is the uh, resistance of the winding of R phase, Y phase and B phase, but this resistance is taken from the phase to neutral. Okay, phase to neutral, and this LV resistance is taken from also a phase to neutral. Okay, so first of all we calculate the HP load loss calculation of the HP winding. So first look here, and Y and D11 transformer. Okay, transformer HV winding is a star. Okay, R, Y and B, and LV winding is delta. R, Y and B. Okay, so this is the YND11 transformer. So this branch R, Y and B. Okay, so this is the winding resistance of the HP winding, phase to neutral, and this is also a phase to neutral because resistance taken from the phase to phase, means line voltage, phase to phase resistance taken from the phase to phase, then convert phase to neutral, so multiply by 1.5. Okay, in delta case I tell you, in delta case if you find in delta transformer winding, okay, so resistance measure phase to phase. Okay, if you convert phase to neutral resistance, so multiply by 1.5 multiply this factor in this, you will get phase to neutral. Okay, so R, so resistance phase to neutral of delta winding will be 1.5 into R phase to phase. Okay, in delta case, in delta winding, so this voltage taken phase to phase multiply by 1.5. Okay, so in this way you can calculate the per phase resistance. So HV winding, this is the tap 1 to tap 8, and this is the phase to neutral of R phase, Y phase and B phase, and their average resistance. Okay, and this resistance convert into the 75 degrees Celsius, and their current rating is this, and their load loss is 3I square. Okay, at 39 and convert into to at 39 degrees Celsius, and also convert into load loss at 75 degrees Celsius. Okay, so this is the tap 1 load loss of HV winding. HV winding tap 1 to tap 8, this is the total. Okay, so now LV winding load loss calculation. This is a delta connection, this is the phase per phase resistance, and this is the average, and convert into the 75 degrees Celsius, and this is a rating current, and load loss at 39 degree Celsius and load loss at 75 degrees Celsius. Now talking about the total load loss. Total load loss of this 3-phase transformer will be at tap number 5, 4604 watt. Okay, now this is the calculated load loss. Okay, now this measured loss measured by the power analyzer. Okay, this is the measured loss by power analyzer. Okay, this is the calculated load loss. Okay, now what is the straight loss? Straight loss will be measured loss minus load loss equal to straight load loss. Now straight load loss convert at 75 degrees Celsius is this, and impedance voltage is this. Now percentage Z impedance will be impedance voltage, and this is the percent that calculated is 10.58%. Okay, so this is the percent impedance of percentage impedance of 3-phase transformer. So in this way you can calculate the load loss of HP winding and load loss of LV winding, and then combined at check which tap is the maximum losses, and then calculate the measured load loss and then find the straight load loss. Straight loss will be measured loss minus load loss, calculated load loss. Okay, and then you can find out the percent impedance. Okay, so percent impedance, and this is the impedance voltage. Okay, in this way you can calculate the load loss of the transformer. Okay, if you have any queries, feel free to ask. Okay, thank you.